Bismillahirrahmanirrahim. Assalamu alaikum. Iyaka na'budu wa iyaka nasta'in. Today the topic of our discussion is about homologous series. This is the 7th lesson. So homologous series, these are basically the series of similarly constituted compounds in which all the members possess the same function group and have similar chemical characteristics. We are having that example of methyl alcohol, ethyl alcohol and propyl alcohol, in which we are having the formula CH3OH, CH3CH2OH and CH3CH2CH2OH. As you see that OH is common in all of three cases, so OH representing the presence of alcoholic group, and due to the presence of that functional group they are having the same chemical characteristics. First most important characteristics of homologous series are the similar general formula. All the members of the series can be represented by a general formula. Firstly, we are having the example of alkane, and the general formula of alkane is CnH2n plus 2. If you consider alkanes, they are one of the saturated hydrocarbons, the parent hydrocarbon, and if you talk about methane or you can talk about decane, everyone is compelled to obey that general formula CnH2n plus 2. But when you are having the another situation where carbon is doubly bonded with another carbon atom, then the general formula gets changed and all the members of that alkene family belongs and they satisfied and they follow the formula which is CnH2n rather than CnH2n plus 2. Thirdly, we are having the example of alkyne where carbon shares 3 bonds with another carbon atom and then the formula which they have to obey is CnH2n minus 2. So if we are having alkane family, the molecular general formula or molecular formula of ethane is C2H6, but for ethene it is C2H4, and in case of ethyne it is C2H2. In case of alcohols, we can either write ROH, that R is representing alkyl group and the general formula for alkyl group is CnH2n plus 1 along with OH which is the functional group. In case of carboxylic acid, that CnH2n plus 1 representing R, and over here we are having COH as a functional group. Second foremost important characteristics is the molecular difference between successive homologues. When we move from one member to another, for example, we move from methane to ethane and then ethane to propane and so on, we come to know that every successive member there is addition of 1 carbon and 2 hydrogen atoms and 14 units in their relative molecular mass. The molecular formula of methane is CH4, and by adding 1 more carbon and 2 hydrogen, ethane have molecular formula C2H6 and propane have molecular formula C3H8. If you remember, in each and every cases, there is addition of 1 more carbon and 2 hydrogen in every case, and the molecular mass increases from 16 to 44 and so on. Third important characteristics related to the physical properties, because when we move from methane to decane or pentane and so on, we come to know that there is a regular increase in their boiling and melting point, and this is due to the increase in the molecular mass, molecular size, number of carbon atom, which not only increases the attractive forces but also increasing its molecular masses. In case of methane, the normal boiling point is minus 161, but in case of pentane, it will increase to 36. The normal melting point in case of methane is minus 184, but when you move towards pentane, having 5 carbon in a straight line, the normal melting point changes to minus 130. And these show the increase in the melting and boiling points. As far as the chemical properties are concerned, they contain the same functional groups. That's why they are possessing the same chemical properties. The last and the foremost important thing is that they have same general method of preparation. For example, the track is given to you that if you want to prepare alkane, no matter you are going to prepare methane or decane from it, but the general recipe or the general method is same. For example, in case of you are interested to prepare methane, so the general pattern is The reduction of alkyl halide, where you suggest CH3Br along with nascent hydrogen, you will get methane and HBr. But when you are interested to prepare ethane, you have to follow the same pattern, but just increasing one more carbon, that instead of using methyl bromide, you're going to use ethyl bromide along with nascent hydrogen. In the presence of zinc and dilute HCl, you will get ethane plus hydrogen bromide gas. So, in homologous series, we discuss 5 different points related to the chemical points, chemical properties, physical properties, their method of preparations, their successive members, how these successive members differ by CH2 groups, and they are sharing the general formulas. So I hope this is very helpful for you. We come across with another topic of organic chemistry. Most probably we are going to discuss in the upcoming lectures. We are going to discuss about alkenes. I hope you love to see my videos and you love my videos are basically very helpful for you. Thank you and Allah Hafiz.